Hello out there, dear friends. In this video, guys, we shall be looking at the IUPAC naming of organic compounds. So friends, this is a concept in organic chemistry specifically that most students find it very difficult to understand. But in this video, guys, I promise to make the concept as easy as possible. So guys, in this video, I'm going to cover the following things, guys. First of all, I shall tell you guys the meaning of the acronym IUPAC. Secondly, guys, I shall teach you guys how to name organic compounds. Under that, guys, I shall teach you guys how to name compounds that contain carbon and hydrogen only. I shall also teach you guys how to name compounds that contains other substituent groups, such as we have the group 7 elements, such as that's compounds that have the group 7 elements, compounds that have the OH group, compounds that have the carboxylic acid functional group, those that have the amines, and so on and so forth. So guys, stick around this video, guys. Watch to the end because, guys, it shall be super interesting for you today. Okay, guys, let's now dive in. So friends, what does the acronym IUPAC stands for? This acronym means that International Union of Pure and Applied Chemistry. So friends, it is simply a system of naming wherefore scientists around the globe, they sit around, guys, and agree on a method in which they shall be naming organic compounds. Keep in mind, friends, that carbon forms what? Carbon has the ability to form what, guys? Millions of organic compounds. And a system of naming has to be agreed worldwide to be used by all scientists in order to name organic compounds. Great. If you look that way, friends, I have simply written down a scheme that's a general representation on how we shall be naming organic compounds. So guys, each time you see an organic compound that has one carbon atom, the name must start with what? Met. If you see two carbon atoms, the name must start with eth. Three carbon atoms start with prop. Four carbon atoms starts with but. Five carbon atoms pent. Six goes to hex. Seven goes to hept. 8 goes to oct. 9 goes to non. Then, guys, 10 goes to what? Dec, and so on. So, guys, I think the easiest way for us to understand this concept so well is by looking at workout examples. So, friends, I have gone ahead and I've written these examples that I want us to use these examples now and learn this concept so well. So, guys, keep in mind that practice makes perfect. So if you can able now to name these compounds, I shall be giving you guys all the explanations that you need. So if you can go ahead now to name all these organic compound, guys, I think that the concept is going to be super clear. So guys, let's dive in. Okay, now guys, let's start with the first. We have this organic compound, guys. Let's name this organic compound. Now, friends, like I said, the first thing that you try by looking at is to count the longest continuous carbon chain, guys. Okay, let's look at the number of carbon atoms that this compound has. Since it is a straight chain, let's look at the number of carbon atoms. But friends, you go for the longest continuous carbon chain. Okay, let's start, friends. Let's look at this compound. How many carbon atoms does this organic compound has, guys? You can see we have 1, 2, 3, right? It has 3 carbon atoms. So 3 carbon atoms means the name starts with what? Prop, right? The name starts with prop. So guys, we know that the name of this compound must start with prop. So we go ahead and we write prop. Right? Good. Then now, friends, let's look at the nature of bonding. Do you see that all the bonds are single? Great. All the bonds linking these our compounds are single, right? All the bonds that are linking a carbon to carbon are what? Single bonds. So the name, friends, has to end with ANE. Please, ANE. Because, friends, whenever the organic compound has all bonds linking a carbon to carbon atom being single, means this organic compound is an alkane. And as such, guys, an alkane, when naming an alkane, friends, the name of that compound must end with ANE. Okay, wait, so this is what, guys, we have to end it with ANE. Wait, so friends, this compound is what? A propane. So that's the IUPAC name of this compound, guys. Propane. I'll take it again, friends. When you look at this compound, you start by counting the longest continuous carbon chain. How many carbon atoms are here, guys? We have 1, 2, 3, right? We have 3 carbon atoms. Means the name must start with what, guys? Prop, right? Because we have 3 carbon atoms, the name starts with prop. Then now, friends, we look at the nature of bonding of this compound. Do you see that all the bonds linking a carbon to carbon are all single bonds? So single bonds means what, guys? Means this compound is an alkene. An alkene, guys, is simply a homologous series of compounds. Okay, we have alkenes, we have alkenes, we have alkynes. So in this case, the name must end with ane. So this becomes what? Prop, because there are 3 carbon atoms. It's an alkene because all the bonds are single. Means we are going to have what? Propane. Wait, that's it. So guys, this is the IUPAC name of this compound. Now friends, let's look at this. Let's look at this other compound. So friends, again, we count the number of carbon atoms since in this case it's a straight chain, right? Wait, let's count, friends. Do you see that there are 2 carbon atoms here? 2 carbon atoms, friends. So means that the name must start with what? The name must start with eth, right? We have eth. So the name must start with eth. Now guys, let's look at the nature of bonding. Do you see that there are single bonds linking this carbon to carbon? Single bonds, right? So single bonds means what, guys? Means it's an alkene, right? Therefore means the name must end what? ANE. So this has what, guys? Ethane. So guys, this is the IUPAC name for this compound. This is the IUPAC name for this compound as well. Great. That's it. Okay, now guys, let's look at this compound. Of course, guys, don't be so scared by the presence of this double bond, right? Because I promise to make the concept so easy for you. If there's something you've not understood, guys, please drop it in the comment section down below, guys. I'll get back to you as soon as possible. Okay. Now, guys, let's look at this compound. Again, guys, there is no big story to tell, no big story. Let's count the longest continuous carbon chain. In this case, guys, we have what? We have a straight chain, right? So how many carbon atoms are there, guys? We have 1, 2, 3, right? We have 3 carbon atoms. So 3 carbon atoms means the name must start with what, guys? Prop, right? Wait, so this is prop. The name here starts with prop. Now, guys, now friends, in this case now, do you notice that there's a double bond? Compounds that have double bond, guys, are called what? Are called alkenes, okay? Are alkenes. Keep in mind that those that had single were what? Alkenes. In this case, guys, those that have double bonds are what? Alkenes. In such a case, guys, their name must end with E-N-E, okay? It must end with E-N-E since this class of compounds are what? Alkenes. So in this case, guys, this compound has what, guys? The name has to end what, guys? E-N-E, right? Wait, it has to end with E-N-E. But friends, please note that this double bond might be anywhere, okay? It might be anywhere along the same chain. So it is very important for us to give its position, okay? We need to tell which position this double bond is found. Do you see that? Now, guys, do you see that if we try to count, this is carbon number 1, carbon number 2, carbon number 3, right? That's it. But if we count backwards, we are going to have carbon number 1, 2, and 3, right? So what does it mean? This double bond is found where, guys, on carbon number 1, right? If we count from this direction, if we move like this, guys, it is found on what? Carbon number 1, right? But if we move like this, do you see that this guy is found on carbon number 3? In such a case, guys, we take the smallest number, okay? The smallest digit, guys, will do. So in this case now, we can either take 1 and 3, guys, 1 or 3. Yes, 1 or 3. But since 1 is smaller than 3, we go for 1, okay? So this has what, guys? This has to be prop. What position is it found, guys? 1. So we have to have a dash, 1, another dash. Wait, so guys, this compound is prop 1A. Why prop? Because there are 3 carbon atoms here. That's the chain has 3 carbon atoms. 1 means what? The double bond is found on carbon number 1. In means what? There is a double bond. So the name of this compound, guys, is prop 1 in. But friends, we notice that 1 is insignificant, right? 1 is insignificant. So you might as well just take up the 1, okay? Yes, each time you have 1 in this compound, you might as well take it off and just give your compound simply as propene, okay? Just give it as propene, guys. This is perfect for this compound. This as well is also good, okay? But this is more preferable. If you put this perfect, that perfect, guys, still good. But this one makes more sense than this, okay? It makes more sense than this. So I highly appreciate someone that does this. But if you still do this, like I said, still correct, okay? You're still correct, okay? Now, guys, let's look at this compound. Friends, at this point, please pause the video and give it a try. Then unpause it now to check the solution. Done? Okay. Now, friends, do you see that not only do we have a double bond, we also have what? A functional group, right? We have this functional group that is bromine, right? So in such a case, guys, whenever we have halogen functional groups attached to it, we are going to start by putting the halogen in the first position, because in this case we put the double bond in the last position, right? But in this case the halogen groups will come in the first position. So since this is bromine, the name has to start with bromo, and since it's on carbon, and now guys the name has to start with bromo, right? Good. Now friends, let's look at how many carbon atoms are there. We have 1, 2, 3, right? So there are 3 carbon atoms. So this has what? A bromo prop, right? Bromo prop in bromo propane. But like I said, guys, we must have to locate the position of both this bromine atom and the double bond. Now, friends, let's go bit by bit. Let's start with our counting, friends. If we count in this direction, we have 1, 2, 3, right? So this double bond in this case is found on carbon number what? 3, where we count in this direction. But if we count from this end, guys, do you see that we are going to have this guy as 1, 2, 3? So in this case now, guys, this guy is found on carbon number 3 where we go like this, and carbon number 1 where we come like this, right? So in this case, like I said, we take the smallest, which is what? 1. So this has what, guys? A prop 1 in, but like I said, 1 is not necessary to write, right? If it's from 2, perfect, you must specify. 3, you must specify, and so on. But once you have 1, you might keep it like that. Okay, it's accepted, perfect. Then our friends, let's locate where bromine is found. But friends, keep in mind that when you are counting like this, you must continue, okay? Because if you are counting like this becomes carbon number 1, this number 2, this number 3. So bromine is found on carbon number 3, right? When you're trying to name it, guys, you must choose a direction. You always choose a direction that is closer to the main functional group. The main functional group in this case, guys, is the double bond, okay? This double bond is a main functional group in this case. So it has the word propane. Then, friends, which position is bromine found? 1, 2, 3. So it's on carbon number 3, right? So this becomes what, guys? 3 bromopropane, guys. So this becomes the name of this our compound, guys. The IUPAC name is 3-bromopropane. Why 3? Because the bromine atom is found where, guys? On carbon number 3. Wait. Okay, friends, let's look at this compound. Let's look at this. So, friends, do you see that not only do we have a double bond, we have what, guys? 2 of them, right? We have 2 of them. 2, guys. And just that not only do we have a chloro compound, we have 2 of them, right? So the name is some kind of cumbersome. But friends, don't bother yourself. Like I said, we are going to make everything in this video very, very easy. Okay. Now, guys, let's take bit by bit. First of all, guys, we count the longest continuous carbon chain. We have 1, 2, 3, 4. We have 4 carbon atoms, right? So 4 means what? The name will start with what? But, right? So we start from somewhere. We have but, right? Good. Now, guys, do you see that there's double bond, right? So this becomes what? A but in, right? This is an alkene, means the name must end what, guys? E-N-E, right? But do you see that there are 2 double bonds? We have to give the position of those double bonds, but keep in mind, friends, keep in mind that we have 2 bonds, means what? We have to go with what, guys? A di, right? So this is a but, but what a diene. A diene, guys, this is it. We have a diene. Why this word die? Because there are two of them. Okay, if it was three, we are going to have what try, right, and so on, guys. So this has what a built a diene. So we are going to have what, guys? We are going to have a die in this case, since there are two of them. Okay, there are two of them. But friends, we must locate the position of these bonds. Let's start, guys. If we start from here, we're going to have 1, 2, 3, 4, right? So there's a double bond found on carbon number 1 and on what number 3, right? If we label from this way, we are going to have 1, 2, 3, 4. So in any of the ways in which you go, guys, the naming becomes the same because this is carbon number 1, carbon number 3 when counting from this direction. But if you're coming like this, guys, do you start it remains the same because this is still carbon number 1 and carbon number what? 3. So that's it, guys. So this has what a diene. Let's look at the position of those double bonds. It is found on carbon number 1 and carbon number 3, right? So we name this one is going to what built 1 because the first is found on carbon number 1 and the second is found where, guys, carbon number 3. So we're going to have built 1, 3 diene, right? Perfect. So it has to be built 1, 3 diene. But friends, we must locate where this chlorine compounds are found, guys. We must locate them. So do you see that in this case, if we count from this end, this chlorine is found where, guys, on carbon number 2 and 3, right? In this direction, it's still found what carbon number 2 and 3. So this compound has to be, we are going to have 2 because one chlorine atom is found where, guys, on carbon number 2 and 3, right? But before then, guys, before we even going for their numbering, do you see that there are 2 chlorine compounds and it has what a dichloro, right? It has what a dichloro. So this compound is going to what, guys? A dichloro compound. Okay. And again, guys, since it is found on carbon number 2 and 3, so it has what, guys? 2, 3 dichlorobutane 1, 3 diene, guys. Perfect, guys. Perfect. That is the IUPAC name of this compound. So, guys, make sure you subscribe to this channel, guys, if you want to have more of this. In our channel, guys, we offer contents on biology, chemistry, physics, mathematics, further mathematics, computer science, and so on and so forth, guys. Visit the channel, guys, Humble Mark Academy. We have so many interesting contents for you guys. We even have a pamphlet that is the advanced level chemistry that has past questions and solutions in both paper 1, 2, and 3. So, guys, get a document. It's going to help you so much. Okay. Now, guys, if there's something that is so that you think you don't understand about this naming, guys, please drop it in the comment section down below, guys, and I promise to get back to you as soon as possible. Okay. Now, guys, the last compound has to be this, right? Let's look how we can name this compound first. Let's look. Okay. Now, guys, do you see that not only do we have, oh my God, friends, we have what? We have triple bonds, right? We have this triple bond here, guys. And friends, a triple bond means what? This compound is an alkyne. And friends, for alkynes, the names must end what, guys? Must end with YNE. Okay? It has what an alkyne, so the name must end what? YNE. And since there are 2 carbon atoms, the name must start with what, guys? Eth. So this is what we have, eth. Since it's an alkyne, and friends, if you want to look at the position of this alkyne, since we have those 2 carbon atoms, it cannot be found on anywhere except position 1. So this is, we have 1, 2. In fact, it is on 1 even 1, 2 in this direction. Here in this direction is at position 1. So we're going to have eth 1 in. We can have eth 1 in. But since this ethene, we have those 2 carbon atoms, guys, the 1 is not important. So we can just name it as oh my God, friends, I'm sorry, it's not in, guys, it's ein. So we are going to have ethyne. Please, we're going to have ethyne. So this is the name for this compound. Great. So friends, now that we've seen how to name compounds of such, namely single bonds, double bond, triple bond, guys, when we have these halogen compounds attached to it. Let's now go forward now to look at how we can name compounds that have, we have carboxylate functional group, alcohol functional group, and so on, guys. Let's go.